I've only got 7 minutes. All right, continued question 17. It says a particle is moving according to x equals 4 cos 3t minus 6 sine 3t. Now, when you've got cos and sine like that, we generally use auxiliary angle method. Now, it says prove that acceleration is proportional to displacement but is oppositely directed, hence prove that it's simple harmonic. You can differentiate. What do we get? X is 4 times, yeah. Is it negative? Yeah. 4 times negative 3 sine 3t minus, the other one will stay the same sign, but change to cos. So you get negative 12 sine 3t minus 18 cos 3t. And acceleration, we're using x double dot is negative. The sign won't change now. What do we get? Negative what? Negative 36 cos 3t. But the sign will change for the cos. Plus 18 times 3. 54 sine 3t. So, girls, I'm sure you can do this. Now, to prove that it's simple harmonic, girls, you want acceleration is negative n squared x. So let's just put our x in. I would pull this out first and then fill in the gap. Negative 9. I pull out the x because that has to be there. See, that's negative 9, which is negative 3 squared x. So therefore, it's of the form. Acceleration is negative n squared x. Therefore, it's simple harmonic motion. As acceleration, all right, this is what proportional means. That's the proportional symbol. Acceleration is proportional to x. But when you replace, so we know that as one gets bigger, the other one gets bigger. That's what proportional is. Or when one gets smaller, the other one gets smaller. But to work out the constant of proportionality, so x times something gives acceleration. That's what it means. And once you've worked out what that constant is that you times x by to get a, you write it as equals k. But in this case, we're going equals negative n squared x. So our constant of proportionality is negative n squared x. Normally, it'll be times, like x times something gives a. That means they're proportional. When you see the line y equals 2x, that means y is proportional to x. And the constant is 2. As x gets bigger, y gets bigger. That's what it means when two quantities are proportional. When they're inversely proportional, you'll see this. When x gets bigger, y gets smaller, you see. They're not proportional, they're inversely proportional. So that's inverse proportional. Okay. So, therefore, we can say that, can you just write the conclusion? Therefore, acceleration proportional to displacement, but opposite direction.
How do you put it opposite?
Because you've got negative n squared times x gives a. When x is, say,
so every time we prove simple harmonic, it's always
yes, but in opposite direction. Because acceleration's positive when x is negative. Because n squared is going to be positive, and negative times a negative gives a positive. Now that's part A. Now part B. It says find the period, the amplitude, and maximum speed of the particle. Now look at it. It's not in the form that you can find anything with. So we need to rearrange the 4 cos 3t minus 6 sine 3t into either a cos curve or a sine curve. So we've got that x equals that, so I'm going to go cos. So it's equal to, so x equals 4 cos 3t minus 6 sine 3t. I'm going to put it in the form of, do you remember if the cos is first, you can do the cos version, but the sine's different?
It's different.
So cos of 3t, it's got to be 3t plus alpha. Okay, now, so look, keep the sign the same. Always works for sine. So the cos one's first, we go cos, sine's different. That's your theta, the 3t. I'd be putting the negative 6 first. swap them around. Yeah. So you get R, isn't cos minus sine? Cos. So R cos 3t cos alpha minus R sine 3t. I don't like to use it. You could, I suppose, if you can remember it. Sine alpha, which is, remember we swapped them around, cos alpha cos 3t minus R sine alpha sine 3t. So therefore what equals what? Therefore R cos alpha is, well, the cos 3t's are the same. R cos alpha is 4. R sine alpha is 6. Cos alpha is 4 on R. Sine alpha is 6 on R. Drawing your triangle. Yes, you can do that other thing if you want. Cos 4 on R, sine 6 on R. Alpha is, tan of alpha is 6 on 4. So alpha is tan to the minus 1 of 6 on 4. Why am I working it out? Just one sec. What's R? Square root of 4 squared plus 6 squared. Square root of 52. 2 root 13. Now, just one sec. That maximum speed is when x is 0. Just leave that at the moment. From part A, we know that acceleration is negative n squared x or negative 9x. Do you remember we got that from part A? So now we can do d by dx of a half v squared is negative 9x. So therefore a half v squared is the integral of negative 9x dx. If you differentiate that, you get that. If you integrate that, you get that. So girls, you know why we're doing this? Because we want a relationship between v and x. When x is 0, tell me the speed. So I know that acceleration is negative 9x from part A. I can replace acceleration with d by dx of a half v squared because there's only 2 or 3 things that you need to pull out too. Acceleration is negative n squared x. Acceleration is d by dx of a half v squared. Whenever you're asked questions on linking velocity with displacement, go there. Okay? Half v squared is negative 9x squared on 2 plus c. You might think we don't know anything, but we do. Because on the ends, when v is 0, we know the amplitude. When v is 0, x is 2 root 13. So, when v is 0, x is 2 root 13, or why don't we just put square root 52 to make it easier. So we get a half times, if v square root 52, it was square root 52, wasn't it? It's just 52 for v squared. Am I doing the right thing? No, I did the wrong one. A half of 0 is negative 9 times 52 on 2 plus c. Oh, what's that? 52 on 26 times 9, 260 minus 26, 230. What's wrong? What's wrong? Okay, so therefore a half v squared equals, what have I got? Negative 9 x squared on 2 plus 234, multiply through by 2, v squared is negative 9x squared plus 468. Good. Now, we've got an equation. So, find the period. Have we found that?
Yeah.
Period is 2 pi on?
13.
No.
Wait, what?
What's n from part 1? Yep. So girls, we've got a period from part 1 already. So we want the period. Do we know what n is for the, no, what's a? Do we have it? No, we know the amplitude. The amplitude's 2 root 13. So the amplitude is 2 root 13. The period, got to go back to part A, is 2 pi on n, which is 2 pi on 3. That's done. The maximum speed is when, is when x is 0. So you're going to put that in now and work it out. And the acceleration, okay, and then we've got to work out the acceleration when x is root 13. All right, we'll get there in a minute. I need to turn the page. All right, yeah, 1 sec. V squared is negative 9x squared plus, what did it say? Negative 9x squared plus 468. So, when x is 0, you can work out v. And that one's pretty easy. They want the speed, whatever that equals, you can work it out. It's 6 root 13 apparently. So speed, you don't need plus or minus. Do they want speed? So speed, maximum speed, 6 root 13. But then, this is what we've got, girls. X is 0, 2 root 13, negative 2 root 13. What are they asking for the last bit? Find the acceleration when the particle is halfway between the mean position and one of its extremities. So the last part's asking you to find acceleration when x is what? What's halfway between... Well, isn't it that plus that divided by 2? Isn't that just root 13? Oh, all right. Okay, so just find acceleration when x is root 13. Don't we have a formula for that? Negative 9x. So it's just negative 9 root 13. Okay? All right, I think they asked for absolute value of. Anyway, it's when that's x. When x is positive root 13, it's in the negative direction. And when x is negative root 13, acceleration will be in the positive direction. Sorry? Because halfway between 0 and 2 root 13 is root 13. Because the amplitude's 2 root 13, we worked out that the end position from the page before. Girls, this is all on worksheets